Okay, I'm back. And if you watched my last video, I kind of said goodbye, so I wasn't expecting to be back. Reason is I'm a teacher in time zone Z, so I don't get access to other time zones papers this early on. However, a viewer emailed me the HL copy of analysis and approaches from time zone A and B, because apparently y'all had the same time zone, or not time zone, same paper. So thank you, Sargeras. So normally I would skip the SL questions because I went through the SL paper first. Unfortunately, that's not the case, so I'll be going through the whole thing. So this is kind of going to be a longer video, which means that I'm going to try to work quickly. And also, a lot of people have been complaining by comparing with our time zones paper that this one was much more difficult. So I guess I have to focus a little bit more. But anyways, again, thank you Sargeras or Sargius for emailing me this. And let's get started. So as I was reading this, we have this thingy radius of 4, and then the length of PQR is 10. And then we just want to find the perimeter, and that's straightforward. We just add the 3 sides together, which is 18. And then we want to find theta. So we know from the arc length formula that 10 should be equal to the radius 4 times theta. So theta is 10 over 4. You can reduce that if you want to, but I need to save some time. Plus IB doesn't deduct marks for reducing fractions or not reducing fractions. Find the area of the shaded sector. So that's 1/2. So 1/2 r squared times theta, I think. So like that. And then no calculator, 4 divides with 4, and then 2 divides with that 4, which is 2. 2 times 10, 20. Okay, not so bad. Next one. Okay, what do we have? Rational, SL rational function. Okay, what is the vertical asymptote? They kind of already tell you. It's where you have a non-permissible value or discontinuity. 2, because you cannot divide by 0, you will have a vertical asymptote where x is 2, because 2 minus 2 is 0. Again, this is an SL function. I guess you guys are HL, so you would have to worry about whether or not it's removable. But of course, it doesn't. There's no like cancellation happening, so it has to be a vertical asymptote. The horizontal asymptote. So I'm just going to rearrange the function. So the main part is this, and this normally has a horizontal asymptote at 0. And then there's a vertical reflection that happens. So normally it goes like that, but then it will look like this. And then this is a translation up 1 space, which includes the horizontal asymptote. So now the horizontal asymptote should be at 1. Another way you can look at it is take the limit. As x goes to infinity, this part of the function goes to 0. So you're just left with 1. Okay. Okay, nice. Find the x and y intercepts. So if I plug in 0, I'll have 1 minus 1 over negative 2, which is plus 1 over 2, so 1.5. I don't know if they want it as a coordinate, so I'll just write it as a coordinate. And then solve for when the actual function is 0. Okay, and then you can solve this using algebra. You can think about it. The only way this is 0 is if this is 1. The only way that this is 1 is if this is 1. So The only way x minus 2 is 1 is if x is 3. So we have a coordinate 3, 0. Okay, is that it? No, looks like there's more on the next page. Okay, this is pretty standard so far. So now we use parts A and B and make a quick little sketch. So vertical asymptote, horizontal asymptote, y-intercept, x-intercept, and then sketch it out. Okay, nice. Only worth 1 mark though. That should be worth more. Okay, and then the next one looks like a pretty standard probability question. PA is this, P given B is that, union is that. Find PB. Okay, so we're gonna use the conditional formula right now. Which is this. And then we don't know what this is, but it is related to the union because we do have a second formula for A union B, which is A plus B minus the intersection. Okay, and then what we're gonna do is we're going to rearrange this union formula so that we have PA union B. Or sorry, PA intersection B. So this is gonna be PA plus PB minus the union. Okay, and then this is kind of a lot of writing. I'm gonna replace all my values. So this I'm trying to find out, so I can call that x. It's kind of ugly looking on the screen. I know this is what, 0.4, and then this is 0.55, and then this over here is 0.25. So now if I substitute that in here, I'm gonna have 0.25 is equal to 0.4 minus 0.5 is 0.55 is gonna be negative 0.15, I think. And then from here we solve this. So multiply the x over to the left side from the denominator. Collect your x's together, so 0.15 over here, 1 minus 0.25 is 0.75, and then that means we have x is 0.15 over 0.75, and then this isn't technically an exact number because you can't have decimals in a fraction technically, so we're going to write it as 15 over 75, and then you can reduce if you want, but that's kind of a waste of time. Okay, that one I'm pretty sure I've seen in an exam before. And then this one looks awfully familiar, like I've seen this exact graph on a former question. I'm pretty sure I've seen this question maybe with slightly different values from another exam. Okay, so you have a function, and then if you integrate from 0 to c, you get this area. The area is natural log 3, and then we need to find out what value c is. Okay, so we're going to integrate from 0 to c of this function. And then we'll equate this to natural log 3 and then go from there. Okay, so what do we have? You can do u substitution. So du is 2x dx, and then that means dx is 1 over 2x du, and then that changes my boundaries as well. So this should be 2 now, and then this is c squared plus 2. And then what happens is I have a 1/2 here, so I'll just take that out of the integral. This x will cancel out with this x. So you're left with 1 over u du, and then that's a pretty straightforward integral. This is just natural log u, and then evaluated from 2 to c squared plus 2. Right, let me just double check. U is x squared plus 2, x is always positive, u is always positive, so you don't need to include absolute value. Usually IB is pretty good with that. Okay, evaluate this integral, or use fundamental theorem of calculus. Natural log c squared plus 2 minus natural log 2. Okay, and then this should be equal to natural log 3. And then from here, we need to solve this log equation. So first, I'm going to use logarithm laws to combine these together by dividing the inside. This 2 1/2 multiplies as a 2 here, and then that becomes an exponent of the 3, so that I have 3 squared, and then because I have one log is equal to another, that just means that the insides are equal to each other. And then 3 squared is 9, so multiply the 2 over, and then subtract the 2, which means that this needs to be square root of 16, positive, because c is clearly positive. Okay, not bad. Okay, I'm on question 5. Okay, I am a little worried if this takes more than an hour and a half, because I only have an hour and a half to do this. So I gotta actually speed run through this. So there will probably be more mistakes than usual, as if I don't always make mistakes. Okay, we have 2 functions. We make a composition. F goes into g, so this goes into x's, and then the result should be this. Okay, so I'm gonna make a composition, and then the plan is that we expand it out, and then we just compare coefficients, because we know what the coefficients should be. So what the heck is this? A squared x squared plus 2abx plus b squared plus ax plus b plus 3. Okay, so the only term that has x squared is this a squared term. That means that 4 needs to be a squared. So a could be plus or minus 2. So, okay, that makes sense because they want 2 different functions. And then I have a positive 2ab and the plus a as my coefficients of x. So those added together should be negative 14. In other words, I have 2ab plus a needs to equal to negative 14. And then from here we can find out what b is, depending on what a is. So if a is positive 2, then we'll have 4 times b plus 2 is negative 14. So this is negative 16. So b is negative 4. And then if a is negative 2, then I'll have negative 4b minus 2. Sorry if you hear my cat. She's meowing a lot. Okay, we have that. Negative 4b minus 12. B is positive 3. Okay, so your 2 functions are negative 2x plus 3, and then positive 2x minus 4. Okay. Gotta go, gotta hurry up. So far, it's not bad. Okay, but that was all SL questions, I'm gonna guess. So here's our first actual HL exclusive question, because it's a continuous random variable. State the expected value in terms of A. Okay, 1 mark, so this should be pretty easy, right? I'm just gonna do the integral. There's probably a faster way to do this if it's only 1 mark. Okay, from your formula booklet, expected value is integral from, and then it's x times f of x. Okay, so then this is 1 over 2a. 1/2 x squared from 3a to a. So this is 1 over 4a times 3a squared minus a squared. So then, so this is the 4, right? This is 9. 9 minus 1 is 8. So I have 8a squared. This will cancel with that 8 and get 2. This a divides with this a squared. So I have 2a, right? Okay. That should be worth more than 1 mark if you have to calculate it, which means that there's a faster way. I just can't really think of it right now. Use integration to find the variance. Okay, now the formula booklet. Variance, this is the one with the integral. Okay, and then you have 2 options. We just found out the mean because the expected value is the mean, so I'm gonna, this one looks ugly, I'm gonna use this one because the mean is outside of the integral. Okay, variance of x is integral, I think it was x squared, right? Minus the mean squared. Okay, so same thing, we're gonna integrate this. If it's x squared, then this is 1/3 x cubed. Okay, and then this is 1 over 6a, and then if we're cubing 3a, then we get 27a cubed minus a cubed. So 27 minus 1 is 26 a cubed. A divides with this a to make a squared. 26 and 6 reduce to 3 and 13, right? Divide both by 2. Okay, so then currently I have 13 over 3a squared, and then 4 is 12 over 3, so I'm going to subtract 12 over 3a squared. So this becomes 1 over 3a squared. Okay, not so bad. Induction is looking like it's next. And it's a summation induction, so those are pretty easy to have your assumption show up. Okay, so step 1. N equals 1. So this is from 1 to 1 of this. So that's 1 over 2 factorial, which is 1 over 2. And then on the other side, we have 1 minus 1 over 2 factorial, which is also 1 over 2. So both sides are the same, so it's true. Okay, and then we're gonna make our assumption. And then I'm kind of doing the shorthand, of course. there's like, I would need to say like, you know, this is true, and then assume blah 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 blah, but you know, trying to do this quick. Okay, so here's our assumption that this is equal to 1 minus k plus 1 factorial, right? Yeah. Okay, and then from here, now we start our proof, or the hard part of the proof. For k plus 1, we have k plus 1, 1, all of this stuff again. And then I like to write on the side what I want. Basically, I need to use my assumption somehow and show that this is equal to 1 minus k plus 1 plus 1 factorial. So I need this to be k plus 2 factorial. Okay, so because it's a summation, I can have my assumption show up by summing only to 1, or only from 1 to k. And then I just add on the extra term, which is the k plus 1 term. Okay, and then my assumption is right here. So I know that this is 1 minus 1 over k plus 1 factorial, like that. And then we're basically done. I just have to add these two terms. So first off, I need a common denominator. So this is where I need to multiply this by k plus 2. And then if you add them together, I think you're done, right? So this is k plus 2 as a common denominator. And then you have k minus k, so those cancel. And then you have 1 minus 2, which is negative 1, right? Yeah, negative 1. And then you're done. Not bad. Damn, still more short answers? Okay, how am I doing for time? Okay, it's been 22 minutes. Making good time. Okay, what do we have? F and G. Okay, they're gonna intersect at point P. Okay, with x coordinate k, k is something. Show this. Okay, so when they intersect, then that means that these two values should be the same, right? And then of course, tan is sine k divided by cosine k. So just multiply this over here and then you're done. Okay, hence show that the tangent curve in the tangent curve. Okay, so the tangents of both of these are going to be perpendicular. They intersect at right angles. So that means we need to find their tangent gradient at the value k. So f was cosine, so then this is equal to sinc, negative sine k. G is secant squared k. Okay, and then we need to show that these are perpendicular, which basically means that if you multiply these together, it should equal to negative 1, because they're negative reciprocals of each other. Okay, so from there, I'm going to use, it says hence, so you're going to use part A. Hopefully you can see where there's a cosine squared, because secant squared is just the reciprocal right there. And then we can use part A. And then these clearly are equal to negative 1. So you know they're perpendicular. Okay, and then find the value of sine k. Well, okay. I only have one equation, I think. Okay, so we're just going to solve this formula here. So first we use the Pythagoras identity so that everything is written in terms of the sine ratio. And then this is a quadratic for sine. So, you know, this is a good sign because if you look, they want you to kind of use the quadratic formula. So rearranging everything, you'll get positive this plus sine k that minus 1 equals 0. Okay, so then that means that sine k is quadratic formula negative b plus or minus. Oh, they just want plus. Okay. Plus the square root of b squared minus 4 times a times c divided by 2 times a. What the heck is this? 1 plus 4? Okay. There you go. Done. Okay. Long answer? No, not yet. This looks vector question. Probably some adding and subtracting vector geometric stuff. Okay. Parallelogram. OA is A. OC is C. OC is twice the length of A. Okay. Sure. The angle between these two is theta, as shown. M is along here so that AM is apart some ratio proportion of A to B. So K is, yeah, 0 to 1. And then OM dot MC is 0. OM, yeah, 90 degrees. Okay. Okay, so first off, AB is also C, which means that A to M is K times C. And then express OM and MC in terms of A and C. So OM's right here. So you can see that by vector addition, it's this vector plus that vector. So OM is A plus KC. And then M to C, this is a vector subtraction of OM and OC. And then I always forget what the order is. So I want it to end here, right? So if I go this way, it would go that way. Okay. So I need to go backwards that way and that way. Okay. So this is C minus OM. So OM is A plus KC. So this is A minus KC. And then I guess I'll collect my C's together. Like that. Okay. 2 marks. Hence, use the vector method to show this is equal to 0. Well, the only thing you know is equal to 0 is the scalar product of these two, the dot product. So I guess I'll do that. So then A plus KC dotted with this one. 1 plus K, I think this was C, right? And then minus A. Okay, and then we need to expand this out. So if you don't know, a scalar product, you can kind of treat it like a regular multiplication. So we can expand this out kind of like a polynomial. So this one is going to dot with that one. So you have 1 minus k at a dot c, and then you can multiply it with that one. So that's 1 minus a dot a, and then we continue with the kc. So next up is k1 minus k at c dot c, and then minus k a dot c. And then we're going to also use the fact that two vectors together is the two lengths times the angle. So this is good because I need the angle to show up in the expression. Okay, this is 3 marks. Am I doing this the most efficient way? I have no idea. Oh yeah, and then if you dot a vector with itself, the angle between them is 0, so obviously cosine 0 is just 1. Gotta go. And speed up. Okay, not bad. And then there's no length of C. Why? Do I know the length of C? Oh, right here. C is twice the length of A. Oh my god. Okay, so then this is 2 1 minus k length of A squared cosine minus length of A squared plus 2 times 2 length of A squared is 4 length of A squared. So I'm just gonna write the 4 in the front. Oh my god. And then 2k A squared cosine theta. Okay, this is looking pretty good. So first we factor out that, and then we deal with this. Okay. How is this only 3 marks? Am I doing this in such a long and convoluted method? Okay, I'm gonna multiply the 2 in. And then I'm gonna move the other cosine term beside it to stay organized. And then I'm gonna multiply the 4k in. And then minus 1. Okay, so that goes there. This one is there. And then that one is there. Okay, so I need to factor this. So this has a common factor of 1 minus 2k. Okay. So if I collect these two together, I'll have 2 minus 4k. Okay. And then these are factorable? Probably. Yeah, okay, we're done. Okay. Is there a 2? There's got to be a 2 in front of this cosine. Yeah, okay. We take out the 2. And then this is it, right? Yeah. Okay, so then we factor this. That becomes that. Factor out the 2. You have that. As you can see, they both have that common factor that we need, so then we're done. Only 3 marks? Crazy. Find the range of values theta such that there are two possible positions for M. You mean like... Okay. Well, luckily, they gave us this factored equation. So... And we know that this should always be 0. So from... And then you have to solve for theta. So from my second factor, this one, I know that 2 cosine theta minus this stuff needs to be equal to 0, or could be equal to 0. Right? This could be 0 to make the equation 0. So from here, cosine is going to be in terms of k. Is that it? No, because they don't say in terms of k. But what the heck is k? K is this, right? Oh, k can be between 0 to 1. So that means that cosine theta can be between when k is 0, so 1/2, to when k is 1, which would be -1/2. So theta is cosine of 1/2 pi over 3 to an obtuse angle 2 pi over 3. Okay, but then this is one solution. And then they said something about 2 possible solutions. I mean, there's also this solution here when k is 1/2. I don't know what angle this is though. But there's a second angle when k is 1/2, right? And then, or sorry, there's a second position for M when k is 1/2. And then there's another position for M here. But I don't know what angle this is. Hold on, let me think about this geometrically. So like, your angle can go like this, and then there's obviously like 2 positions where you have a right triangle along the line. Okay, there's always one at 1/2, regardless of what the angle is. And then because k is a slider, so there's always one at like, here, let me draw this out. So there's always a 90-degree angle here. And then theta is fixed. Is theta fixed? No, theta depends on k, or does k depend on theta? Okay, theta's fixed, which means that there should be a second k, you know. There should be a second k value somewhere. Like here. So, as long as you're from here to here, you should have 2 answers, right? Oh, unless they overlap. Okay, what happens to cosine when k is theta? So 1 minus whatever. 2k over 2, right? So okay, if k is 1/2, then this is 1, so you'll have cosine 0. So okay, I see. Okay, I understand now. So as long as theta is between these two values, then there's gonna be a k value that exists between 0 and 1, so that the second factor is 0. In other words, we have an actual position for m. That k value doesn't necessarily need to be 1/2, because I was getting this mixed up. I thought like theta depended on k, but it's the other way around. And then, so there you're gonna have a k value that may or may not be 1/2. That gives you a perpendicular spot. Along with that, because of this factor, it will always be perpendicular when k is halfway. So for a specific angle, there's usually two spots. Halfway through and somewhere else, according to this relationship between the two. However, if your angle's pi over 2, then that k value that's associated with the angle is 1/2, right? And then I'm working backwards. So if k is 1/2, then theta has to be 2, pi over 2, which means that k being 1/2 is a solution for both factors, which means that there's only one solution at pi over 2. And so that means that we have two solutions anywhere between these two values except for here. Yeah, okay, I don't want to write that because I've wasted way too much time thinking about this one. And that makes sense geometrically speaking. If your thing is 90 degrees. Yeah, okay. Hopefully that makes sense. I gotta move on. Finally, I'm on the long answer ones. Okay, this one looks like an optimization question. I really hope that I can make it in time. Okay, circle, radius 3, P, Q, R. R is right below Q. For point Q, show that this. Okay, so we just solve for y, right? So y is equal to plus or minus the square root of 9 minus x squared from our original circle equation. And then y has to be positive, right? Because this is for q. Q is the one on top. So you have to choose this one, not the one with the negative. Okay, hence find an expression for A, triangle PQR. Okay, so I'm gonna split this in half, and then I basically have two right triangles. And then here's my origin. So this right here has a height of y, which I know is 9 minus x squared. This distance here is x, and then because this is at 3, this distance is 3, so the total distance is 3 plus x. So it's also a right triangle, so this is 2 times 1/2, so then these will cancel. The base times the height Okay, so here's my area. These will cancel. So then next up, take the derivative. Okay, this is just a pretty straightforward product rule. That one, and then take the derivative of the square root one. So that's 1/2. How do I write this? I'm gonna write it underneath. And then chain rule -2x here. Okay, so okay, simplify, and I think they just want this all together. So this goes with that. And I need this to have a common denominator, so I'm going to multiply this by √9 minus x squared, and then that's nice for the denominator, for the numerator, because then the square roots will give me the whole thing in the numerator. And then what do I have? I have -x, and then I need to multiply it in here. So I'll have minus x squared minus 6x. And then am I done? Oh wait, no. Whoops, I don't have a 2 anymore. So this is just 3. And then, yeah, I'm done, I think. Yeah, and then these two obviously are the minus 2x squared that I need to show here. Okay, nice. And so otherwise, find the coordinate so that whatever is the maximum. Okay, so now we set our derivative to 0. And then if you're solving some sort of fractional, rational type thing, we basically just solve for the numerator being 0. And then I don't like having a leading coefficient be negative. Move everything over, factor, hey, 3 plus minus 3/2 -3, and then obviously x has to be a positive value, so x needs to be 3/2. Okay, and then what do I need to do? Find the y coordinate of r. Which one's r? Oh, okay, they want that one. Okay, so then plug this in. This is the negative one. It's kind of tricky, to be honest. Most people would probably find the y coordinate of the other one, because that's what you focused on in part A. That's a little mean, IB. A little mean for you. As if they're not always mean. 9, 4, what is this then? 36/4? What's 36 minus 9? 27? Okay, there you go. Okay, not bad. Ooh, complex numbers. With polynomials. Okay, how am I doing for time? Not bad. 50 minutes. Okay, here's a complex number. Find the modulus argument form. Show it's this. Okay, so we're gonna graph it on the argand diagram. So here's 1. That's our real part, -1. Here's my imaginary part, which is √3. So here is your complex number u. If you use Pythagoras, this is 2. This is going to be a reference angle of π/3, which means your argument is 2π/3, and then as you can see, those go in there. Nice. Okay, part B. Find the smallest positive integer n so that u to the n is a real number. Okay, so this is pretty straightforward question. Actually, I'm gonna write here. So if you want a real number, then that means that your complex number doesn't have an imaginary part. So its argument needs to be some multiple of pi. Okay, and then we know that if you raise a complex number to a power, the argument of that, or raise something to an exponent, the argument of the power is equal to just n times the argument of the base, which was 2 pi over 3. Okay, so n is the smallest positive integer. So the only way for this to be a multiple of pi, the smallest possible number is if n is 3. Because then this is 3, and then that will cancel with that 3. Nice. Okay, find the value of un. Okay, so so if you raise it to the power 3, then un is basically 2 to the power 3, and then the argument, is it a negative 2 or a positive? Wait, hold on. If n is 3, then my angle's 2 pi, right? So I'm a positive number. Okay. So my argument's 2 pi, which means that I just raise the modulus to the power 3, and I get positive 8. Okay, not bad, not bad. Consider polynomial. Given u as a root, find the other roots. Okay, straightforward. Okay, so u is a root. So what was this? Negative 1 plus root 3i. So this means that the conjugate's a root. So negative 1 minus root 3i. And then we should have a third root. I guess we'll call it z3. And this should be a real valued number. And what we're going to do is we are going to use Vieta's formulas and look at the coefficient of the second term. So that's positive 5. So this is the negative sum of the roots. So negative 5 should be equal to adding these roots together. And then this is nice because obviously the complex parts cancel because of their conjugates. Oh man, okay. So what is this? Negative 2. So your third root should be this. Okay. Damn, this is a 9-mark question. By using a suitable transformation from z to w or otherwise, find the roots of this equation instead. Like function transformations? Hold on, let me just write this down here so I can work with it. Is there a transformation you can do? I mean, there must be because they're saying it. But this is kind of giving like binomial expansion theorem vibes. Because essentially what happens is you have the same coefficients, but instead of descending powers of z, you have ascending powers of w. Can I use the... And I know the roots. Ah, okay. Okay, I don't think this is how you're supposed to do it, because I don't know what they mean by transformations, to be honest. But I'm gonna use this little tidbit about polynomials. So let's say, for example, you have this. This is going to expand. And make this polynomial here. Now the coefficients are not affected by the variable. The coefficients are made by the coefficients and constants in each binomial. So if I, and then notice that if I have z in the first term, then as I expand it out, I get descending powers of z. So if I write this with a w here, then this will have ascending powers of w if you were to expand it out. But the coefficients all stay the same. So if I just erase the z, then I don't have the z's anymore. And what I've done is I've basically like kind of shown what I wanted to do, which is have the same coefficients in the same spots, but just have it in ascending powers of another variable, in this case w. Okay, and then I already know what the factored form of this polynomial is because I know what the roots are. Nice, okay. So hopefully you get what I mean. So again, I know the three roots of the z polynomial. -3. Okay, so then all I do is I just get rid of the z and then add a w beside the second term. And then if I expand this out, this should give me that polynomial. And then this is easy to solve for 0 because it's already factored for us. So that means that w is 1 divided by u, 1 divided by the conjugate of u, and then 1 negative 1 over 3. Okay, and then we already know what u is. Because I'm dividing, I'm going to keep it in modulus argument form. So w is 1 over 2 e to the negative 2 pi over 3i. And then the conjugate would be the other way around, so this is positive 2 over 3i, and then of course we have the real valued one. I'm not sure if this is right, because I feel like I'm not doing it using transformations. I don't even know what they really mean by that right now. But I mean, this makes sense in my head. So we're gonna stick with it. Let me know in the comments if I'm wrong and that, or like what they mean by transformations. Okay, consider this equation like a different one. Express this, find the roots of this equation. Okay, this one looks pretty straightforward. So we want to solve this. And then the way we do that is we write z as a plus bi. And then essentially you're going to equate the real and imaginary coefficients on both sides of the equation. So multiply this out. A squared minus b squared. That's your real part. 2abi. And then you got 2a minus 2bi. Okay, so now this one is equal to this one, and then this one is equal to this one. Yeah, okay, I'm gonna start with the imaginary part because that one looks easier to solve. Because if you just look at this, this basically means that a has to be -1. And then that means that from this one, -1 squared is 1, minus b squared needs to be equal to 2 times -1, so -2. So b squared needs to be equal to 3, so b is plus or minus 3, and then do they tell me if I only need 1? Oh, it just says find the roots, so there should be 2 roots. Okay, so then you're kind of done, right? Z is equal to 1 plus or minus root 3i. Done. Okay. This one's pretty straightforward aside from this one with the W thing. That's kind of weird. I haven't seen anything like that before. Okay. And then I think this is the last one, because this is the third long question. And this looks kind of weird. And then let me just see. Yeah, okay, this is the last one. How am I doing for time? 1 hour in. Pretty good. Sorry if my explanations aren't as thorough, because I'm just trying to do this as fast as possible. Okay. Using substitution, integrate this. What kind of substitution? Like U substitution? Ugh, okay, this one looks kind of weird. I'm gonna do what they say. And make a U substitution. And I have some hesitancy with this, and maybe I should be doing integration by parts. But they did say substitution. So hopefully you guys will see where I'm coming from with my hesitancy. Because normally once you do your U substitution, there's going to be like, there will be an X in your DX substitution, but that usually cancels with something. But there's nothing to cancel with, because you don't want both U and X to be in your integrand after you make a U substitution. Should I do integration by parts? Wait, huh? Oh, well, okay, that is U, right? Because I said it was U, so maybe... And then now I have to integrate this instead. Is this any easier? Well, I have a polynomial multiplied by a trigonometric function. Okay. I think I can integrate this one using integration by parts. And then, because this definitely looks like you need integration by parts somewhere. So I'm just gonna say U is U. So du is U, du. And then dv is cosine U dx. So v is sine U. Okay, so this is u times v. So here's u sine u. Okay. Oh, okay. That's a good sign. That's u sine u. And then minus the integral of v du. So sine u du. Wait, where's my 2? I needed 2. I have a... Oh, I forgot my 2. There should be a 2 out here. So that means that this has a 2, and this has a 2. Okay, and then 2u sine u. What's the integral sign? Negative cosine? So this is plus 2 cosine u plus c. Okay, and then we're done, right? Because u is square root x. Okay, nice. That one was kind of funky. I haven't seen a u substitution like this in IB before. I've seen it in, like, you know, regular calculus classes. But, okay. A little tricky. Here is the graph of cosine root x. It will intersect along here. Oh. Okay, apparently they have a formula for where the x value of each intersection is. Write down a similar expression for xn plus 1. Okay, that's pretty straightforward, right? If we just plug in xn plus 1 into the formula. So if I plug in n plus 1, then it's 2n plus 2 minus 1. So 2n plus 2 minus 1 is plus 1. Okay, that's 1 mark, so yeah, that sounds about right. And the regions bounded by the curve and the x-axis are denoted as R1, R2, R3. Okay, calculate the region Rn. Give your answer in this form. K positive. Okay, so these areas are the integral from one intercept to the next. So for Rn, right, this is from xn to xn plus 1 of cosine root x, your function, here. Okay, and then we know what that function is. So this is going to be, what was it, 2 square root x. Actually, let me just write it right now. 2 root x sine root x plus 2 cosine root x. And then we don't need the c because this is a definite integral now. Like that. Yeah. Ew, and then I have to plug in like this. I mean, it's not that bad because these are perfect squares and I square root them. But this is just kind of long. How many marks is this question? 7? Nasty. Okay. 2. And then I'm going to square root xn plus 1. So I'm going to square root this. Okay. Let me just copy paste this so I don't keep scrolling around. Okay, for reference. That's this one, and then I will also need xn, which they gave me here. Okay, so I need to square root both of these things, right? Square root this. And square root this. Okay, so then this is gonna be 2n plus 1 times pi divided by 2. And then sine of the same thing, right? 2n plus 1 over 2 pi here plus 2 cosine the same thing, and then I also need to subtract when I plug in xn. So this is 2 square root the xn Damn, this is pretty nasty. 2n minus 1 over 2 pi minus 2 cosine 2 n minus 1 over 2 pi. Alright, right? This is the square root of xn plus 1. This is the square root of xn. And then, do I have to keep simplifying this? Give your answer in this form. So everything simplifies into like something times n times pi. Okay. Okay. I do see that there's multiples of some fraction of pi in each of these, so something's probably going to cancel out, right? Because there shouldn't be any more trig functions in your final answer. Hold on, so this is odd halves. So this is like 1/2 pi or like 3/2 pi. Same thing here. 3/2 pi, 5/2 pi. Okay, depending on what n is, this will either, because n is at least 1, right? So this is either 3/2 pi or more, and it's always an odd half. Same thing here, it's an odd half, but because it's minus 1, you have 1/2 pi or more. Okay, so if n is 1, this is 3/2. This one is 1/2. If n is 2, then that's 5/2. And then these ones are 3/2. Okay, okay. This is kind of nice. These are going to be 0 because cosine is 0 at odd halves of pi. So like here and here, right? And then this expression only gives you odd halves of pi. Okay. And then at odd halves of pi, sign alternates between -1 and 1. Okay, so this might work out pretty nicely. Okay, and then 2, 2, 2 cancels with 2. Okay, so this is what I have so far. Damn, this is a funky question. I don't like that. This 7 marks? I'm pretty sure I spent more than 7 minutes on this. Oh god, okay. Okay, so when n is 1, this is 3/2 of pi. This is 1/2 of pi. Which means that this is going to be, sine will be -1 here, and sine will be +1 here. So this expression will simplify to negative 2n plus 1 pi minus 2n minus 1 pi. Okay. So we will have negative 4n pi, and then this is minus 1 pi, and then this is going to be plus 1 pi, so let's cancel that one. Okay, so this looks pretty good. This is what they wanted the answer to be, right? Like, at least in this form. K needs to be positive. But I got a negative. What? Okay. Well, okay, let me try it when n is 2. This will probably give you the positive version. So when n is 2, then this one starts at 5/3 of pi. And then this one starts at 3/2 of pi. So this one is now +1. And then this one is now -1, the sine value. So I'll have 2n plus 1 pi plus 2n minus 1 pi. Because this negative and that negative make the plus. And then this is the same thing, just positive. So here. So it alternates between these two. And it depends on what the n value is. So why are they saying that it's positive when there's two different ones depending on what n is? Okay, if n is odd, you can look at the diagram. They'll be negative, which makes sense. And then even ends would be above, so positive. I don't think you can write this as one answer. But why do they want this to be, why do they only want the positive for? Do they only care about like the scalar area and not the signed area? But it's below the graph and they don't say. Whatever. I don't have time for this. There you go. 4n pi. Hence, show that the areas of the regions bounded by the curve R1, R2, R3 form an arithmetic sequence. You can't form an arithmetic sequence if it alternates between positive and negative. They must be ignoring the fact that this is negative. Is it the wording? Bounded? Are bounded areas just positive? I don't think so. If it's below, then it's negative. But they should have worded this one better. Okay. All of these questions about the area will make sense if you ignore the signage and you're just looking at the scalar absolute value of your things, because then this makes sense, because regardless of whether or not you're positive or negative, it's always 4n times pi. And then if it's, you're always considering the positive areas, then you can make an arithmetic sequence. Okay, so then this is pretty straightforward because we know the previous part. So all we got to do is show that Rn plus 1 minus Rn is a common difference d. And then we have an expression for Rn right here. So 4n plus 1 pi minus 4n pi. The 4n pi's cancel out. So this one will cancel that one. So all you're left with is a constant, right? 4 pi, right? And then that's a constant. So this is a constant. So arithmetic. Okay, what's my time? 1 hour 20. Wow, pretty fast. Yeah, okay. There you go, guys. Overall, I'm going to agree with y'all from Time Zone AB. This was... Some questions were more difficult. Like, obviously the first couple ones are SL, so like, if you're an HL student, who cares? This one wasn't so bad. This one, induction, was pretty easy. This one was pretty straightforward, a little tricky. This one was pretty gnarly. From B onwards, I don't know why this question was only 3 marks. This should have been like maybe 5 marks. And C, because of this 2 possible positions of M thing, that one is definitely tricky. This one was very straightforward, the first long question. Just be careful with finding the y value of r, which is the negative one. This complex one was pretty straightforward except for this W question. I don't know how many of the 9 marks it's worth. I'm probably gonna say it's worth like 5 out of the 4. And then the first part is worth 4 marks. This one was weird. I still don't really know what they mean by transformations of Z to W. But it did say otherwise, right? Yeah, so maybe my method is right. So maybe these are the right answers that I found out. The second part was straightforward. This is like straight out of a textbook. And then the last question, this one was weird, man. This one was difficult. Like this one, you had to do a U substitution and then realize that the U will show up in the DX substitution again. And then you do an integration by parts to get what you want. And then you need to simplify this region. Like this is crazy. And then even then, I'm still confused about why it has to be positive. I think they should have specified that, because there's no way, again, like I said, that you can do these last 2 questions if you're considering the signed area. You have to consider the absolute value of each area. And then if you do, it's okay. Like this part is tough, and then you can't really do this part without this part. I mean, I guess you can just assume k is some constant, and then instead when you subtract it, you'll have k pi. Yeah. So you guys had a harder exam. But you know what? That's fine. Because Time Zone C, the Americas, we got other things to deal with. Like dying when you come to school. So give us an easier exam. That's fine. Okay, I will probably go through the other ones when I have time. But thank you for watching. See you later.